They take a sequence of mathematical operations using equations, arithmetic, algebra, calculus, logic, and probability, and translate them into a computer code. They are fed with data from the real world, given an objective, and set to work crunching through the calculations to achieve their aim. They are what makes computer science an actual science, and in the process have fueled many of the most miraculous modern achievements made by machines. There's an almost uncountable number of different algorithms. Each has its own goals, its own idiosyncrasies, its clever quirks and drawbacks, and there is no consensus on how best to group them. But broadly speaking, it can be useful to think of the real-world tasks they perform in four main categories. Prioritization, making an ordered list. Google search predicts the page you're looking for by ranking one result over another. Netflix suggests which films you might like to watch next. Your TomTom selects your fastest route. All use a mathematical process to order the vast array of possible choices. Deep Blue was also essentially a prioritization algorithm, reviewing all the possible moves on the chessboard and calculating which would give the best chance of victory. Classification, picking a category. As soon as I hit my late 20s, I was bombarded by adverts for diamond rings on Facebook. And once I eventually got married, adverts for pregnancy tests followed me around the internet. For these mild irritations, I had classification algorithms to thank. These algorithms, loved by advertisers, run behind the scenes and classify you as someone interested in those things on the basis of your characteristics. They might be right too, but it's still annoying when adverts for fertility kits pop up on your laptop in the middle of a meeting. There are algorithms that can automatically classify and remove inappropriate content on YouTube, algorithms that will label your holiday photos for you, and algorithms that can scan your handwriting and classify each mark on the page as a letter of the alphabet. Association, finding links. Association is all about finding and marking relationships between things. Dating algorithms such as OkCupid have association at their core, looking for connections between members and suggesting matches based on the findings. Amazon's recommendation engine uses a similar idea, connecting your interests to those of past customers. It's what led to this intriguing shopping suggestion that confronted Reddit user Kubobatat after buying a baseball bat on Amazon. Perhaps you'll be interested in this balaclava. Filtering, isolating what's important. Algorithms often need to remove some information to focus on what's important, to separate the signal from the noise. Sometimes they do this literally. Speech recognition algorithms like those running inside Siri, Alexa, and Cortana first need to filter out your voice from the background noise before they can get to work on deciphering what you're saying. Sometimes they do it figuratively. Facebook and Twitter filter stories that relate to your known interests to design your own personalized feed. The vast majority of algorithms will be built to perform a combination of these tasks. Take Uber Pool, for instance, which matches prospective customers with others heading in the same direction. Given your start point and your end point, it has to filter through the possible routes that could get you home, look for connections with other users headed in the same direction, and pick one group to assign you to, all while prioritizing routes with the fewest turns for the driver to make the ride as efficient as possible. So that's what algorithms can do. Now, how do they manage to do it? Well, again, while the possibilities are practically endless, there is a way to distill things. You can think of the approaches taken by algorithms as broadly fitting into two key paradigms, both of which we'll meet in this book. Rule-based algorithms. The first type are rule-based. Their instructions are constructed by a human and are direct and unambiguous. You can imagine these algorithms as following the logic of a cake recipe. Step 1, do this. Step 2, if this, then that. That's not to imply that these algorithms are simple. There's plenty of room to build powerful programs within this paradigm. Machine learning algorithms.